All right, number 1, it says solve for the missing side length in the following right triangles. Then tell if the triangle is a Pythagorean triple by circling Y for yes or N for no. So that's how the test will start. It's a Pythagorean triple if all 3 side lengths are whole numbers. Okay? So if it couldn't be written as with a radical attached, if you have, for example, a number that's a perfect square, and so you end up with all 3 sides are whole numbers, then it is a triple. Otherwise, it's not. If one of them is a decimal approximation, or if you could write it in simplified radical form with a radical attached that can't be, you can't take the square root of it, then it's not a triple. That's the idea on these. So on number 1 here, we're going to go ahead and use the Pythagorean theorem. So we have 7 squared plus 4 squared equals x squared. And 7 squared plus 4 squared is 49 plus 16 equals x squared. So that's 65 equals x squared, or x equals the square root of 65. Now, 65 is not a perfect square, so we would get a decimal approximation if we did that. I think it's about 8 point, well, a little bigger than 8, right? What did you plug in already? About 8.1, 8.06, I think. You could actually just leave it as square root of 65 on these problems. I'd be fine with that. And then just mark this is not a triple, because that hypotenuse is not a whole number. The other 2 were, but the hypotenuse is not, so it's not a triple. So it's not a matter of memorizing the list of triples I gave you. That's not going to do any good, because how many triples are there in existence? An infinite number, because you could take the triple 3, 4, 5 and create another one by multiplying it by 2, right? 6, 8, 10. So just go ahead and solve it. If you get a whole number, it's a triple. If not, then it's not. Here we're going to solve for x. Now, x in this case is a side length. So I have x squared plus 9 squared equals 15 squared. That's my setup. You got to be sure that you get the 15 on the other side of the equation. It's the hypotenuse. Don't just grab these 2 lengths and square them and set it equal to x squared. The 15 has to be over by itself here. So I have x squared plus 81 equals 225. If I subtract 81 from each side, I get x squared equals, what's 225 minus 81? Got 144. Yep. And then take the square root of each side, the positive square root. So square root of 144 happens to be a whole number. Whole number is 12. So I've got this 9, 12, 15. All whole numbers, so therefore this is a triple. So we would mark yes on there. And if you recognize the triples, like as you're going through, if you see a 3 and a 4 and you know the flip side of the 5, you can just skip the Pythagorean theorem, answer it, and mark it as a triple. If you see like the 5, 12, 13 might show up on there. 5, 12, 13 is a pretty common one. 3, 4, 5, or 6, 8, 10, like on the quiz, I think 6, 8, 10 showed up. If you recognize the triples, you don't need to show any work. Just mark it as a triple and give me the flip side. If you're in doubt, go ahead and use the Pythagorean theorem and just check it. All right, number 3, it says find the values of the variables. So find these missing side lengths, but this time it says leave answers as simplified radicals. Now I'm giving you the fact that this is a 45-degree angle, this is a right triangle, meaning this other angle is also 45. I'm giving you the hypotenuse, right? So if I'm giving you the hypotenuse and I need to work backwards to the leg, a couple different ways I told you. The big idea way is to just go ahead and divide by root 2, right? So if we are given the hypotenuse in the special 45, 45 right triangle, we divide by root 2. Can't leave our solution like that, right? With the root 2 in the bottom. So we're going to rationalize the denominator. In other words, get rid of that root 2 in the bottom. And we do that by, both top and bottom, that's right. So we have 14 root 2 on the top. What does the bottom equal? 1. Yeah, just 2, yeah. You're right in terms of the idea that something cancels out here, but it's the radical that cancels out. And we're left with just 2. 14 divided by 2 is 7 root 2. Now I told you there's a little bit of a shortcut that'll work on these 45, 45 rights. Remember what it was? I half the hypotenuse and then put a root 2 on it, multiply by root 2, yeah. But the reason that works is because we must divide by root 2 to get back to here. Both of these legs have to be the same. So I don't want decimal approximations here. You shouldn't be using sine, cosine, or tangent to do this, although you could, but you would get a decimal approximation if you did that, okay? And I don't want that. I want the exact answer in simplified radical form for these. Any questions on that? Yeah. All right, number 4, there will be one like this on there as well. It says, find the sine, cosine, and tangent of angle A as reduced fractions. This is kind of like the bottom of the quiz, ones where I just want you to write the ratio. Don't solve for the angle. Just tell me the ratio using the definition. Now, if I'm going to write the sine, cosine, or cosine of angle A, I need to know the hypotenuse, CA, before I can do that. Because sine is defined to be opposite over hypotenuse, right? So, first of all, I've got to find the hypotenuse. Pythagorean theorem will work fine. This is actually a triple as well. It's if you look at this, this is 3 times 4. This is 4 times 4. So what do you think that last side will be? 5 times 4, yeah. 4, 20, yes. So you could use the idea of triples to solve that, or use the Pythagorean theorem either way. I'm not going to go through the Pythagorean theorem again today. So, okay, either way. So that means the sine, we'll abbreviate it SIN, of angle A is going to be equal to, if I'm at angle A, it's going to be equal to the opposite over hypotenuse. You may even want to write down, when you get your test, our little acronym here, SOHCAHTOA, for helping us to remember the relationships that that we've been using. So there it is. Sine of A is O opposite over H hypotenuse. This is my opposite over here. 12 is my opposite. The hypotenuse is my 20, and the adjacent is my 16. So it's O over H, or 12 over 16, and I'm going to ask you to reduce that. So 12 over 16 reduces to 3 over 4, that's right. And so that's reduced form. Yeah. Oh, yes, that's why you're looking at me funny. You're right. Sorry. Yeah, it's opposite over hypotenuse, so it should be 12 over 20 is the correct one. Yes, you're right. So opposite is 12, hypotenuse is 20. Yeah, I just did the tangent ratio. We'll get to that one. But sine is opposite over hypotenuse, and that's going to reduce to 3 over 5. Thank you. Cosine of A is equal to adjacent over hypotenuse. So the adjacent is 16, and the hypotenuse is 20. Yep, and that reduces to 4/5. And then tangent of A is going to be the one that I did earlier. I did 12 over 16, which reduces to 3/4. So that's what I'm looking for on that one. It's just the ratios of the sides that correspond to the sine, cosine, or tangent of an angle. Any questions on that? All right. Next one. Now we're going to actually use our sine, cosine, or tangent ratios to solve for the missing side length here. Notice I'm only given one side length and an angle measurement. And the angle measurement is not a 45, nor is it a 30, nor is it a 60, right? So I'm limited on what I can use to solve for the missing side length in these right triangles. I'm going to go ahead and write this down again. There's our SOHCAHTOA, that's an H right there. So if I'm staying at the 24-degree angle, the two things that are involved in the labeling here, the 8 and the X. What is the 8? Yep. So put a little A there, and the X is the hypotenuse. So which of these three? Cosine is going to be used. So we have cosine 24 degrees equals adjacent 8 over hypotenuse x. And we can cross multiply and solve, or some of you are plugging it in first to your calculator, getting the decimal that corresponds to cosine of 24. That's fine. In the end, we discovered that by the cross product property here, these two, cosine of 24 and x, will change position. So we're going to end up with x equals 8 over cosine of 24 degrees. And if we solve for x first, it will reduce our round-up there. Yeah? Yep, it matters. So in the cut part here, we have CAH. The A corresponds to the adjacent, and that goes on the top.
So it goes up before the H?
Yep.
So
That's how you know which one goes on top, and it does matter. The definition for cosine is adjacent, length of the adjacent side over length of the hypotenuse. And the hypotenuse, you'll notice, is on the bottom in each of these. So just keep that in mind. And then we solve this with our calculator. And what do you get? 8 divided by cosine of 24. Make sure you're in degree mode. Might even be worthwhile here. I could even show you here what it looks like. Let me pull up the calculator here. We'll do it on here, and then everybody can see how it's done. What'd you guys get? And then what do you need to do after you get your answer on these? What's a good idea?
round of the nearest.
Probably I'll ask you to round to the nearest tenth. The other thing you should do is take a step back and just ask yourself, does my answer make sense? So I'm going to make sure I'm in degree mode. You can see it's highlighted right here. What's that? So 8 divided by cosine of 24. And we get our 8.8 if we round to the nearest 10. That's what it looks like on my set of calculators. X is about equal to 8.8. What's the setup on the next one, number 6 here?
Tangent.
It is tangent. We've got the x is the O opposite. The 24 is the A adjacent. So we've got tangent of 31 degrees equals x over 24. So you see on there, Gabe, the O and then the A, so the order is decided. And on this one, when we cross multiply, we are going to end up multiplying the 24 by tangent 31. So if we cross multiply, we have x equals 24 tangent 31 degrees. So each time you'll either be dividing by the trig function, whatever length is given, or multiplying by it. So if we plug this into the calculator, it's 24 tangent, what was the angle again? 31 degrees. And we've got 14.4. Make sure that makes sense. So x is about equal to 14.4. And we can box our answer. There it is. Any questions on those? Yeah.
Wouldn't it be x over 14.4?
No, it's x equals 14.4 approximately. Our setup was x over 24. We're solving for x. All right, number 7, it says solve the right triangle by finding the missing parts here. So I would probably start with the angles here. That's probably the easiest thing to start with. We've got a 90 here and a 68. And we know 90 and 68 add up to 158. So that leaves me with 180 minus 158 over here. It's 22 degrees, that's right. The other way you could do it is you've always got a 90 in these right triangles, so just subtract this from 90, you've got your 22. Either way. So I've got my 22 degrees for angle B. We'll fill that in. Now, if I want to find A, I've got a couple of options here. I could go from the 68-degree angle or the 22-degree angle, either one. It's probably safer, just in case I made a subtraction error to get that 22 degrees, it's probably better to go with the 68-degree angle, the one given, just to be safe. So if I am at the 60-degree angle and I want to solve for A, what setup should I use? If 68-degree angle, A would be O, this would be adjacent, and this would be H hypotenuse. This is tangent again, so I've got tangent of 68 equals A over 7. I go ahead and cross multiply. A is equal to 7 tangent 68. And could somebody pop that into a calculator quickly and tell me what 7 tangent 68 is? Do we have agreement on that? 2.3, okay. Sounds reasonable. You know, it's bigger than this 7 looks like, and that makes sense. We'll see what our hypotenuse is now. What setup do I need to use to get my hypotenuse if I want to use the 68-degree angle and the 7 that's given to me? So I want to use the ones that are given. It would be cosine. Yeah, we're involving A and H. So it would be cosine of 68 degrees equals A adjacent over C hypotenuse. Now in this case, you know, the C is on the bottom of the fraction here. We're going to change spots for these two. So I have C equals, write it over here, C equals 7 over cosine of 68 degrees. So we type that into our calculator. And what do you get? Yep. You could cross multiply here if you want, and when you cross multiply, you get you know, the C cosine 68 degrees equals 7. But to solve for C, you're going to have to divide each side by cosine of 68. That's true. That'll work every time. Yeah. There's a lot of different ways to get to this final setup here. But what do we get for a solution? 18.7. 18.7. Okay. That's it. So that's completely solving for a right triangle, which is our ultimate goal, being able to find all the angles and all the sides of any right triangle, given a certain information. Good. All right. Now there's some. There will be some word problems on here, some applied problems. Okay. Stuff like number 8. It says the short leg of a 30, 60, 90 triangle is 4 centimeters long. So just draw the picture. Draw your 30, 60, 90 triangle. I know my 30 is opposite my shortest side. The 60 will be over here. And they tell me the short leg is 4 centimeters long. So that side opposite the 30 has to be my 4 centimeters long. And so if I need to find the other two sides, I can use my special right triangle, 30, 60, 90. Remember that the ratio for the 30, 60, 90 goes like this. If the shortest side is x, the side opposite the 60-degree angle is x times the square root of 3. And the side opposite, or the hypotenuse, I should say, is double the shortest side. So in this case, if x is 4, what is the side opposite to 60? 4 square root of 3, that's right. And the hypotenuse is 8. And I've labeled it, taken care of it. Okay. So stuff like that, where you'll just need to draw the picture and label the side lengths. So once again, we started with a short leg of 4. 4 times the square root of 3 is going to be our side opposite to 60. And 8, which is double the shortest side, is our hypotenuse. So here's the mean kid problem here. You're aiming a bottle rocket at a cat in a tree. Your launcher is 26 feet from the base of the tree. The cat is 17 feet up the tree. So cat 17 feet up the tree. Your launcher is 26 feet from the base of the tree. The question is, what angle of elevation? Remember, angle of elevation is up from your line of sight. So here you are down at the ground. you're trying to find this angle x. So this involves inverse trig, right? We're finding the angle measurement. It's going to involve inverse trig. What's the setup going to be for this one?
Tangent.
Tangent, yep, whoops. Sorry here. It's going to be tangent of x equals,
26 over 7.
well, this is the opposite though, and this is the adjacent. Remember we have O and then A, so it will be 17 over 26. The way we handle that in our calculator, I like to set it up first. Set it up first, just in case the setup's not quite right, or if you make a mistake on the calculator one way or the other, at least you can see what you're doing. So we go to second, and then hit tangent, and then that fraction, which was 26 over 17, right? That was the other way around. 17 divided by 26. Is that correct? Might have frozen here. What did you get for the angle measurement?
33.7.
Give me grief. The 33.17. Typically on these, I'll probably ask you to just round to the nearest degree. So x is about equal to 33 degrees. Is that right? It's about 33 degrees.
Yeah, it's
33.1785. Okay, so we're just round to the nearest whole 33 degrees. All right, and then this is kind of like the one of the performance test problems, the middle one, the part B. It says looking down from the edge of a 30-meter cliff. So looking down from the edge. Okay, that means if I am, let's draw a triangle here. I'm looking down from the edge of a 30-meter cliff. Let's do a dash line here. That would mean this is 30 meters right here. Meaning over here, I also have 30 meters. Okay. I mean, my angle of depression is measured from the horizontal down. And if I measure an angle of depression of 14 degrees, not a real steep one, so I'm looking, way out to sea. I spot a boat in the ocean. So here's my boat right here. My boat. So how far am I from the boat? We're not talking about this horizontal distance. We're talking about following my line of sight to the boat. It's kind of like the weather balloon problem we did in 8.4. That's the length that is given, or that I'm trying to find. That was the one that was given in that one. But here I am, 30 meters up, 14 degrees angle of depression. We're finding x. So which one is going to be sine? So I've got sine of 14 equals opposite 30 over hypotenuse x. What's the setup to solve for x here? 30 divided by sine of 14. What is 30 divided by sine of 14? And we'll make sure that it makes sense. What do you get for x?
124.
About equal to 124 meters. Does that make sense for this problem? Sounds reasonable. I mean, the cliff's 30 meters up. This is the hypotenuse of my reference triangle. My angle of depression is really not very steep, right? That boat's way out there. Good. So those are the types of word problems you can expect on there. I think there's one that is an airplane coming down, or it could be a boat problem like this, or different things like that. Lots of different problems we can pull from. All right, then we had the idea of the converse of the Pythagorean theorem, and then this is another theorem that comes off of that, the idea that you can tell if I made 3 lengths, as long as there are 3 lengths that will make a triangle, you can decide if the triangle is a cube of cubes or right, based on that comparison. So if we take, notice they're not in any kind of order here, but we're going to compare the largest side, the 19, to the 8 squared plus 17 squared. So we're going to check and see if the 19 squared is equal to those, or if it's bigger or less. And that'll decide if it's acute, right, or obtuse. So 19 squared is, I believe, 381.
61.
361, yes. I got 381. 361. And 8 squared is 64. And 17 squared is 289, right? And if you add the 64 and the 289, what do we get? 353. So how does the biggest side squared compare to the sum of the squares of the other two sides? Looks like it's bigger, right? So what has that done to my triangle? We have the c squared is bigger than the other sum of the other two squared. So we have c squared is bigger than, so that's an obtuse one. So this one is obtuse. These I'll definitely need help with. We've got to first scan it and find the biggest side. The biggest side in number 12 is 97. So we'll have to check 97 squared and compare that to 65 squared plus 72 squared. So could somebody tell me what 97 squared is? And then somebody else maybe just go ahead and add the squares of these two. I just want the final 9409 for this. Okay. And what's the sum of these two squares? We'll just skip the squaring each one. But if you could just square each one, add them up, and tell me what number you get. Ah, the same. Okay. Not one of the triples I have memorized, but they end up being the same. That means this is a triple, believe it or not. And what kind of triangle do we have? A right triangle, yes. And of course, if the inequality had been the other way, if the c squared had been less than the sum of the other two squares, then you'd have q. Any questions on that at all? All right, there will be a section of multiple choice. A lot of the special right triangle stuff will show up in there, special right triangle, or even just setting up trig functions. But things like what is the length of the diagonal of a square with a length, side length of 8? If you just draw a picture, that means this is 8 and this is 8. There's my diagonal. I'm trying to find x. You have a couple different ways you could go about this. You could use the Pythagorean theorem if you wanted to. It would work just fine. But this is a special right triangle. It's a 45-45. If I take a square, draw a diagonal, and cut it in half, I've created two 45-degree angles here and here, right? And this is a right angle. So what does x have to be? According to our ratios, remember? It has to be b. Yes, 8 root 2. That's right. It's going to be the side length times root 2. And here's another application of special right triangles. Number 14. What is the area of an equilateral triangle with a side length of 4? So I'll draw my equilateral triangle. Side length of 4. It's equilateral, so that means all three sides have side lengths of 4, right? Now, if I go to find the area of this, area is equal to 1/2 the base times the height. I know the base is 4. Okay. What I don't know is the height. But I can use the idea of special right triangles to find the height. If I draw in my height right here, I've just split this in half. That means this is 2 and this is 2. So what is the height of my triangle? Well, I could use the Pythagorean theorem, but I know that in an equilateral triangle, these are all 60s, right? All three of these angles have to measure 60 degrees, meaning this right here is 60 degrees. And up here, that leaves me with a 30-degree angle, and then here's my 90. So if this is the 60-degree angle and the shortest side is 2, what is the height of my equilateral triangle?
1.
No. No, this is, I think I heard it.
2 square root.
2 square root of 3, yeah. It's the hypotenuse that's double the shortest side. But the side opposite the 60 is going to be 2 root 3. Let me blow this thing up. I'll make it a little bigger here for you. Here's what we have. Here's my 60-degree angle here. Here's my hypotenuse at 4, and my shortest side at 2, right? So here's my 2 and my 4. There's my 1 to 2 or 2 to 1 ratio. So this other side ends up being 2 root 3. And I can pop that in for my height. So area equals 1/2 4 times 2 root 3. What does that product end up being? You see it up there? It is C. Yes, 4 root 3 is the correct answer choice. Yes. Notice that it's written in radical form, simplified radical form. All right. What about 15? 15, there's a way to handle this really quickly and easily if you know your triples. What goes with 5 and 12? Remember? This is one that's worth knowing when you're going in the set. Yes, do you remember, Dave? 13. 13 does. So this side is 13. Why do I need that side? Well, I asked for cosine of r. Cosine of r is going to be, here's r right here, adjacent over hypotenuse. So I have an adjacent of 5 and a hypotenuse of 13. There it is right there. I don't know. Fourth choice that you would hopefully throw out. So 5 over 13. Yeah. All right, a couple more here. Number 16, it says, which equation would not give AC? Okay, that's, all right, let's call this AC right here, or X. So which equation would not give you the length of AC? So I start with, this says cosine of 68. That means we're using this angle up here. Cosine of 68 equals AC over 27. So what they're saying is cosine is equal to the AC is opposite, 27 is hypotenuse. There's something not quite right with that, right? Cosine is not defined to be opposite over hypotenuse, it's adjacent over hypotenuse. So that one's out, which is what we're looking for, right? Yeah, hey, we lucked out. You know, that means these other 3 are all equivalent statements, okay? Which is to say that there's more than one way to find the missing side length. If you're given a hypotenuse and a leg, you can use the Pythagorean theorem to find it. If you wanted to, you could use cosine of 22, then it would be adjacent over hypotenuse. So this one's set up right. And would tangent work as well? I think so. Opposite over, yeah, adjacent works just fine. So these 3 all work. This one is the one that does not work, so we circle that one. Those are always difficult ones in the multiple choice, especially if it's not the first one that's the wrong one. You just have to check each one. Okay. And then the last one on here, in triangle XYZ, angle Z is a right angle. So we'll say Z is the right angle. Y is equal to 72 degrees, so we'll make this Y up here, the 72. Meaning X is going to be 18 degrees. You with me? Just drawing the picture. I'm just filling in the parts here. It says, which equation would give XY? XY happens to be the hypotenuse. And then it looks like they've solved for the hypotenuse. So we have a couple equations with sine in it. If I'm standing at, let's see, a couple equations with sine of 72. Let's just check that. If I set it up, and this may take a little bit of work, sine of 72 would be equal to the opposite, which it looks like instead of using a single variable, they're using the length of the segment. So opposite in this case would be xz over xy. I don't have any equations that look like that yet. But it looks like they've solved for xy in each case. So here, if I solve for xy, by swapping these two, I'm going to have xy equals xz over sine of 72 degrees, right? It is right there. Does that match any of those? Looks like it does, yeah. I mean, yeah. I'm just noticing sine. Here's a cosine in here, here's a tangent. If neither of these match this, I would have to go and try the cosine setup, okay, or the tangent setup until I find one that matches. But draw a picture. Make sure you know. You might want to write down on your test right away. The two special right triangles, draw them out. The x root 2, the x root 3, 2x. Write down SOHCAHTOA on there right away. Things like that. Make sure you have the same calculator you're using all through the unit. So come with a new one. They have more of them today with that. It's not good yet. You're in degree mode.